Welcome back, children, to your online classes for maths. This is day 3 of your learning session. We'll continue with our lesson, integers. Before we go forward, let us see what all we had learned yesterday. We had done word problems on addition and subtraction of integers. We had done comparing of integers, and we had learned a new thing, which is the magic square. Children, here are some questions for you to try out. I'll give you 1 minute to solve these questions. Okay, time's up. Children, you have already learned some of the properties of integers in class 6. Now, these are some new properties that you have to learn in class 7th. So let us move forward and see what are these properties of integers. Now, children, in the book, properties of addition of integers and properties of subtraction of integers is given together. But I will take it separately and let us see each property of addition and subtraction separately. The first property that we'll do is the closure property. Closure property says that whenever we are adding two integers, the sum that we get should also be an integer. If it is an integer, then closure property is satisfied. Let us look to some examples. Here 4 plus 2, where 4 and 2 are integers and sum of 4 and 2 gives us 6, which is also an integer. Another example, minus 8 plus minus 4. Again, minus 8 and minus 4 are integers, and when we add these two, we get minus 12, which is also an integer. So here we can say that whenever we add two integers, we always get the sum to be an integer. So this proves that closure property is satisfied for addition of integers. The next topic is the commutative property. Commutative property says that if we add two integers and if we change the orientation and then add, both the sum would be same. And if the sums are same, then we can say that commutative property is satisfied for addition of integers. Now let us look at few examples. Here if we add 4 plus 2 or if we add 2 plus 4, we get the sum as 6. Let us look to another example. If we add minus 8 and minus 4 or minus 4 and minus 8, the sum would be minus 12. So this proves that commutative property for addition of integers is satisfied. The next property is associative property. Associative property says that if we have three integers and if we add them in any order, the sum will always be same. And if the sum is same, then associative property is satisfied for addition of integers. Let us look at one example. Here we are taking the integers 4, 2 and minus 6. So if we add 4 and 2 first and then to the sum of 4 and 2 we add minus 6, we get the answer as 0. And if we add 2 and minus 6 first and to the sum of 2 and minus 6 we add 4, then also we get the answer as 0. This shows that even if we add the numbers in any order, the sum will always be same. And this proves that associative property for addition of integers is satisfied. Now let us look at some of the properties of subtraction of integers which are same as that of addition. The first property is the closure property. Closure property says that whenever you are subtracting any two integers, the difference should also be an integer. If it is an integer, then we say that closure property is satisfied. Let us look to some examples. Minus 6 subtracted by 2. Here minus 6 and 2 are integers and we get the difference as minus 8, which is also an integer. The second example, 5 subtracted by minus 6. Here also 5 and minus 6 are integers and the answer that you get is 11, which is also an integer. So this proves that closure property for subtraction of integers is satisfied. The next property is the commutative property. Commutative property for subtraction says that if we subtract two integers in any order, it will not give the same difference. So this means that commutative property for subtraction of integers is not satisfied. Let us look at one example. Here minus 6 subtracted by 2 gives us minus 8. But if we change the places, that means if we subtract 6 from 2, then we get the answer as 8. Here both the differences are not same, which proves that commutative property for subtraction of integers is not satisfied. The next property is the associative property. Associative property for subtraction of integers says that whenever we are subtracting three integers in any order, the difference will not be same. So this proves that associative property is not satisfied for subtraction of integers. Let us look to one example. Here there are three integers that are given, that is minus 6, 2 and minus 8. If we subtract minus 6 and 2 first and to the difference we subtract minus 8, we get the answer as 0. But if we subtract 2 and minus 8 first and then to the difference we subtract minus 6, we get the answer as minus 16. So this proves that both the differences are different, and this shows that associative property for subtraction of integers is not satisfied. The next topic is additive identity. Additive identity is a number when added to an integer gives the same integer. So when we add 0 to any integer, we get the same integer. Therefore, we can say that 0 is the additive identity for integers. Let us look at few examples. Minus 5 when added to 0 gives us minus 5. 9 when added to 0 gives us 9. 7 when added to 0 gives us 7. Minus 13 added to 0 gives us minus 13. Children, let's look at one question. The question says that write down a pair of integers whose a part is sum is minus 3. Now, according to this question, we can take out any pair of integers whose sum is minus 3. So here I have taken minus 1 and minus 2, but you can take any two numbers. Minus 1 and minus 2 added together gives us minus 3. Now the second question says that the difference is minus 5. Again children, you have to remember that you can take any pair of integers provided the difference should be minus 5. Here I have taken minus 9 and minus 4. Minus 9 subtracted by minus 4. Again, you can see that I have used the rule of sign, and when two similar sign comes together, it becomes another sign. So here it is minus and minus, it becomes plus. So now the next step says that minus 9 plus 4. and here I got the answer as minus 5, which is what the question had asked. Now the C part is saying that the sum should be 0. So again children, you have to remember you can take any pair of number. I have taken here 10, minus 10 and positive 10. Again, when you add minus 10 and plus 10, we get 0. Now children, let us start the exercise 1.2. First question is similar to the example that we did. Now the question says that write down a pair of integers whose sum is minus 7. Difference is minus 10 and sum is 0. Let's look at the first question, first part, that is sum is minus 7. So here also you can take any pair of integers where and if you add those integers you get the sum as minus 7. So I have taken here minus 8 and plus 1. So when I add minus 8 and plus 1, I get the answer, I get the sum as minus 7. B part says that difference is minus 10. So I have to take such a pair of integers whose difference comes out to be minus 10. I've taken here minus 12 and minus 2. You can take any pair of integers. Minus 12 and minus 2 subtracted gives us minus 10. C part, sum is 0. Children, you have to remember that you can take any pair of integer. I've taken here minus 5 and plus 5. Minus 5 and plus 5 when added together gives us 0. Second question, A part. Write the pair of negative integers whose difference gives 8. B part. Write a negative integer and a positive integer whose sum is minus 5. C part. Write a negative integer and a positive integer whose difference is minus 3. Let's look at the first part. It says that write a pair of negative integers whose difference is 8. Here I have taken minus 2 and minus 10. You can take any set of numbers, any pair of numbers. You can also take minus 12 and minus 4. And similarly, you can make many more pairs. Now, since I've taken minus 2 and minus 10, you can see that I'm subtracting both of them. So minus 2 minus minus 10. In the next step, since two signs are coming together, I use the rule of sign, and so it becomes one sign, negative and negative becomes positive. So the next step comes out to be minus 2 plus 10. And minus 2 and plus, because there are two different signs, we will again use the rule of sign and we will subtract the numbers but put the sign of the greater number. So it comes out to be 10 subtracted by 2 gives us 8. But because 10 is the greater number, we put the sign as positive, and so we get the answer as positive 8. Now the next part says write a negative integer and a positive integer whose sum is minus 5. Now you have to remember that you have to take one negative integer and one positive integer. Here I have taken minus 10 and 5, where minus 10 is a negative integer and 5 is a positive integer. You can also take any set of negative and positive integer, but your sum should always come out to be minus 5. Or according to the question. So here, since I have taken minus 10 and 5, let us find the sum. So minus 10 plus 5 gives us 5. Now how did we get the answer as 5? Now you know that whenever you have two numbers with different signs, we always subtract and put the sign of the greater number. Here, since we have minus 10 and plus 5 and they are two different signs, we are subtracting the numbers and we are putting the sign of the greater number, which is 10. So we got the answer as minus 5. Now let's look to the third part, C part. Write a negative integer and a positive integer whose difference is minus 3. So you have to give a negative integer and a positive integer whose difference is minus 3. Here I have taken minus 2 and minus 1. You can make any set of integers provided it should be one negative and one positive integer, and when you are finding out the difference it should come out to be minus 3. So since I have taken minus 2 and minus 1, I am taking the difference of minus 2 and minus 1. So minus 2 minus 1. Here again two numbers with the same sign we always add and put the sign of the greater number. So 2 minus 1 gives us minus 3. Third question. In a quiz, Team A scored minus 40, 10 and 0, and Team B scored 10, 0 and minus 40 in 3 successive rounds. Which team scored more? Can we say that we can add integers in any order? Now let us solve this. They are asking that which team scored the most points. So first step, scores of team A are minus 40, 10 and 0. So total score of team A will be minus 40 plus 10 plus 0. So here you can see that the total score that team A got is minus 30. Now going back to scores of team B. Now what are the scores that team B got? It is 10, 0 and minus 40. So here also we have to find the total score. So total score of team B becomes 10 plus 0 plus bracket minus 40, and the sum comes out to be minus 30. Now as you can see, both the teams scored the same points, right? So it is minus 30 and minus 30. So both the teams have equal scores. Now the second part of the question asks, can we say that we can add integers in any order? As we have seen in the closure property, we can say that integers can be added in any order and the answer or the sum will always remain same. Question 4 says that fill in the blanks to make the statements true. Now the first part is minus 5 plus minus 8 is equal to minus 8 plus dash. Now as you can see here, if it is minus 5 plus minus 8, then it should be minus 8 plus minus 5 using the commutative property. So the blank that is to be filled is minus 5. Second question is minus 53 plus dash is equal to minus 53. Now here you have to see that what should be added to minus 53 to get minus 53. Yes, you have guessed it correct. It is 0. Anything added to 0 gives us the same number. Moving on to the third question. 17 plus dash is equal to 0. So what should be added to 17 to get 0? Yes children, you have to add the additive inverse of the number. Now if the number is 17, its additive inverse would be, yes, you have guessed it correct, minus 17. And if the number is 16, then what will be its additive inverse? Yes, you are again correct, it is minus 16. But if the number is minus 45, then what? What will be its additive inverse? Yes, you are correct, it will be positive 45. Now coming back to the question, let's see that 17 added to negative 17 gives us 0 using the additive inverse. Now fourth question, 13 added to minus 12 plus dash is equal to 13 plus minus 12 plus minus 7. As you can see here, we are using the associative property. So again, by using the associative property, we can say that the blank space should be filled with -7. Now fifth question is -4 plus 15 plus -3 is equal to -4 plus 15 plus dash. Here also you have to see which property you have to use. You have already learned the properties. Now you can see that here by using the associative property we can fill in the blanks with -3 because that is the only number that is left out. Let us now look back to what all we had learned today. We had learned about the properties of addition and subtraction of integers, which were closure property, commutative property, and associative property. Closure property is satisfied for both addition and subtraction. Commutative property is satisfied for addition and not for subtraction. Associative property is satisfied for addition and not for subtraction. We also saw additive identity, which is 0 for integers. Children, I want you to go through these questions and see how much you have understood today's lesson. I'll give you 1 minute for that. Here are some more questions for you to try. These are similar to the ones that we had done above and an example also. So I hope you are able to solve these. The first question is sum is -4. So you have to find out two integers. When you add them, you should get -4. I hope, children, that you understood whatever was taught. We had done closure property, associative property, and commutative property. I hope you have finished with the first and the second part, and I hope that you are starting with the third part. What was closure property? Closure property says that whenever you are adding two integers, the sum should be an integer. And if you are subtracting two integers, then the difference should also be an integer. And if the sum and the difference is an integer, then we can say that closure property is satisfied. I hope, children, you have done C and D part, and I hope that you are starting with the E part. E part says that you have to find two pair of integers whose sum is 10. But children, please remember that you will not use 5 twice. You will not use any integer twice. Try to find out two different pairs of integers. I hope you have done the E and the F part and you are starting with the G part. We did the commutative property. What does commutative property say? Commutative property says that we can add two integers in any order. Even if we change the order, the sum would be same. But is it true for subtraction? I hope you are done with the G and the H part, and I hope you are starting with I part. Difference is minus 11. Again, you have to find out two different integers. When we are finding out the difference, it should give us minus 11. What does associative property say? Associative property also says that when you are adding three integers, we can add them in any order. If we add them in any order, we will get the sum to be same every time. But is it true for subtraction also? I hope you have done with I and J part and you're starting with the K part where difference is 1. I hope you have finished K and L part. I hope you all got your pair of integers and I hope you have seriously done this exercise. That's it for today, children. Hope you will revise whatever we have discussed today and come prepared for the next session tomorrow.